Good evening, everyone. I'm Kamala Gunawardana. I think we all know each other now. A lot of people in the participants, I think we all know, but as a formality, I'm highway consultant and a fellow representative of the IESL Council this session. Today's proceedings also lecture is done by our Professor Jai Singha, Senior Professor of Civil Engineering Sectional Committee, Civil Engineering Department of the University of Moratuwa. So we don't have to go for big introduction because he has been doing about 20 lectures for this session. So actually today's title is a very valuable one, Value Engineering for Highway, Bridges and Flyovers. Actually, he is, I think, according to his abstract, he's going to elaborate mainly the use of high-strength concrete needs a great knowledge on concrete technology and site practices. And since so many different aspects are needed, needs a great knowledge on concrete technology with these high-quality, cost-effective structures, and that will also he will discuss today. So out of main items, the technology greatest strengths up to like 80 megapascals with site mixed concrete will be illustrated, since such optimization is highly pertinent to today's context.
Recording in progress.
High fuel prices and supply chain associated steep price escalations. So with this remark, I wish to say that we are much fortunate that to share more fruitful lectures, programs from Professor Jai Singha, his expertise areas during this session, and on his tenure as the chairman of the Civil Engineering Sectional Committee of the IESL. Without further ado, I invite Professor Jai Singha to take over. Over to you, Professor.
Actually, can the host allow me to share the screen? Can the host allow me to share the screen, please?
Yeah. And I request all the participants to mute your mics throughout the session unless you have to ask the questions. Thank you. Enjoy this lecture.
Can the host allow me to share the screen?
Why you can't?
It does not allow me to open the video. Oh, now it's okay. Now it's okay. Right. So first, I'll give a brief introduction. And so first, I'll do a small comparative study. I'll give two examples and then show you why we need value engineering. So if you take, let's say 4-lane highway, what do we have? First, we have 1.5 meter walkway. Then we need through 2 lanes of 3.5 meter. Then we need another center median 1.2 meter. Then we need 3.5 meter, another 3.5 meter, and another 1.5 meter. So this is the width. So if you add them up, here you get 7 meters. Here you get another 7 meters. So 7, 14, 17, 7, 14, 17, 18.2 meters. This width is 18.2 meters. So if you have a width of 18.2 meters, so you have to see how we get this traditionally. Traditionally, what we do is we make a bridge like this. And then we'll place eye girders at a spacing. If the span is about 30 meters or even 32, 34, in that range, we go for eye girders, and we can generally go up to about 35, even 40 meters, but you have to be mindful about the weight of the structure. The weight of the structure is a very important parameter. Right? Engineer Kamala, I hope you can hear me properly.
Yeah.
Right, okay. No, I'm just checking. Right, okay. So basically what we do is, generally we keep about 1.5 meters here, another 1.5 meters there. And then what we do is we actually create a slab at the top level. And this slab will be about 220 to 250 millimeters thick. And because we need some stiffness, it's always we provide 2 mats of reinforcement. 2 mats of reinforcement. Right? So top mat and the bottom mat. And we have to be very mindful about the behavior this way. So it's likely that we might get 16 millimeter H16 at 150 centimeters. Very, very likely. In the other direction, in the longitudinal direction, we might get H12 at 150 centimeters. So if you do the calculations, you will generally find for crack controlling, we need this type of reinforcement. On the other hand, there's a possibility for going for some little bit of pre-stressing, like you put a pre-stressing tendon here and then pre-stress this way, and we go for about 1.0 newtons per millimeter square pre-stress. That is also okay. 1.0 to 1.5 newtons per millimeter square. Transverse pre-stress also can be used. That is one of the options available for you, but this will be axial pre-stress. And then on top of that, you will get the wearing course. The wearing course will be there, and then there will be handrails. So the road furniture will be there. So basically somewhere in the middle, you'll get the handrail and some curbs. So here also you'll get curbs. All those things will be there. So when you are designing, now because we are having a wide, so this is the pile foundation. So this is a the pile foundation, the pile cap. And on top of pile cap, we actually start this pier. And the width of the pier or the thickness of the pier can be about 1 meter to 1.2 meter. So the pier size can be 1.0 to 1.2 meter. And that will all depend on what you are going to do. So sometimes we go for this type of thing when you look at the section, you see that, we have 1 meter here. And here we have gone for about 2 meters. The idea is, you need space for keeping the beams and, making some kind of connection here. So you need space. And you need a space for keeping the bearings as well. So there will be bearings. So there are so many different factors. And in the early days, people are very worried about many things. One is thermal packing. Number 1. Number 2, shrinkage, creep, use of PT. How to use pre-stress concrete? PT beams. So these will be PT beams, pre-stress concrete beams. And they can be, expansion joints. Then the moment you go for expansion, you get the next problem. What is that? Waterproofing. And then in coal countries, you have to worry about de-icing salts. Because they add salt. So you have to worry about de-icing salt. But in Sri Lanka, fortunately, we don't have that problem. And then you will have another question, simply supported. Or continuous. Then the foundation. You can have a raft foundation or a pile foundation. So one of those. Now you can see on one half sheet, I have shown you the kind of variable. So another variable can be the beams. Beams can be large number of I-beams or few box girders. So many variables. So here, when you look at all these variables, you can see, when you look at all these variables, you can clearly see we can have so many different solutions. And that's where the value engineering comes in. So when you have so many variables, what happens? A brilliant bridge engineer, what will he do? He'll optimize. Average engineer will have so many questions. What are they? 30 megapascal for substructure. Then he might say, I will use 30 megapascals for deck. And deck and beams both form the superstructure, and we might say 40 megapascal for PT beams. And this is also 30 megapascal. Then you'll have foundations. You might say, I'll use 25 megapascal for pile foundation. And when it comes to pile foundation, we have another question. What are we going to do with piles? There can be many options. One is precast. The next option, raft. Third option, board, piles, in situ cast. So in the board pile also you can have so many different options. What are they? One thing is, you can have the pile going with reinforcement to the bottom. And you might even ask, can we have pre-stress? PT in the pile. Can I have PT in the pile? Or you might even ask, can we have a piled raft? Now you can see, when you start with the bridge, we have the lowest foundation. Then we have the substructure. Then you have the superstructure. So all these can have so many variables. We have raft, piles, and piles can have precast, board, in situ cast, and board in situ cast, We can have PT, reinforced, or reinforcement only at the top, 12 meters. So many different variations just in the foundation itself. Then we have to think about the as a substructure. If you want, you can say pile cap is sub foundation or sub pile cap is what is in between substructure and foundation. So if you want, you can put the pile cap to the substructure or you can put it to the foundation. Whatever it is, it doesn't matter, but generally it goes with the foundation because foundation will be completed only when the pile cap is cast. So it's better to go with the pile cap. Then we have piers. Again, we can ask, on top of pier, you can have pier capping beam. And here you can say whether it's PT or reinforced concrete. Piers also can be PT piers or reinforced concrete. Again, so many different options. Superstructure can be reinforced concrete, PT slabs, PT beams, and you can also have more options. PT, transverse PT deck or reinforced concrete deck. So many different things to decide. So we have to first see where we stand in street. And we all know today is 7th. Right. So we can have so many different solutions. So what are those solutions? Before finding the solution, we have to identify the problem. What is the problem? Problem is very straightforward. Concrete. We have cement. Bag is about 3,000 rupees. So that is one problem, because it used to be around 1,000 rupees 3 months ago. So if you have accepted a contract 3 months ago, now you are finished. Because cost of concrete has gone up. Cost of cement alone has increased by 300%. A huge problem. Then we have 20 millimeter aggregates. What is the cost? Maybe about 15,000 rupees a cube, and used to be about 8 to 10,000 rupees. Why? The diesel prices have gone up so much. Now, 1 cube of, we really don't know the exact price because not much construction is going on. But I'm sure with all the difficulties, the lorry drivers will say, the suppliers will say 15,000 rupees because the lorry drivers will say we cannot come for anything less than how much. I mean, they have to spend about the diesel going around 500 rupees a liter. They have to the cost of running the lorry for 1 kilometer will be about 200 rupees. When you consider all the cost like salaries of the lorry drivers, tire wastage, the leasing that you have to pay, when you consider all the costs, the cost of running a lorry for 1 kilometer will be 200 rupees. So if it is 20 kilometers, you buy it from Aturugiri or all those areas where you get quarries. So when you buy from a quarry, and it is about 20 kilometers to come to your site, and so there alone it's 4,000 rupees. But if it is a bigger lorry, it can be even around 300 rupees It's a huge 3-cube lorry. The cost can be around 300 kilometers because they are having very powerful engines. So they might do only about 3 kilometers per liter, especially in the traffic conditions. So they might be charging something like 250 rupees per kilometer. So when you have 20 kilometers, they are on 5,000 rupees, but they have to charge for going back as well. So when you consider all those charges, so going back also you have to charge. So the transport cost will double. Then you will find that, cube is that. Then it comes to sand. Now bringing sand from Mayangan is no longer possible. Why? Because it's far. Just one moment, I'll set up the mobile hotspot. Right, okay. Engineer Kamala, can you see?
Yeah, Professor?
Can you see this?
Can see,
sheet?
but it's, yeah, can see.
Little blurred, is that right?
Yeah.
Just one moment, I'll bring a lamp and then make it little light. The lights are little dim today.
I think we have to proceed, no? Fine. Now it's better, Professor.
How about now?
Yeah, it's better.
All better.
Yeah.
One problem, we don't have sunlight these days. So because of that, we can't charge the batteries with solar. Right. So we have huge problems. So you can see it has nearly doubled the price. Sand may be about 25 to 30,000 a cube, which means we can no longer use river sand. We have to go for manufactured sand. Right? So even the manufactured sand might cost about 50,000 rupees. Used to be about 7,500. Then admixture. Used to be about 400 rupees. Now 800 to 1,000 rupees per liter. Right. So first we look at reasonable concrete mix like 40 megapascal to understand the problem. Now you can see there's a huge problem. And I don't have to tell you about the reinforcement. Used to be about 125,000 a ton. Now it's about 700,000 rupees a ton. We really don't know whether it has gone up even more, even further. And we all know it's because of USA, not because of Russia. So this is the country, with mad people who go and create trouble somewhere. Then two countries fight, and that creates a huge mess in the world. And people of USA, UK, Japan, to a lesser extent, and Australia, they all suffer. The countries that suffer most are what? USA and Australia. Why? They rely on private cars. And Japan, UK, they rely more on bicycles. And Japanese people, they rely a lot on trains and walking. All these countries, walking is not a problem. So they walk a lot. They do cycles, they use trains. But the most affected countries are Australia and USA because they use cars. And there's another country that is very much affected, and that is Sri Lanka. Because we use more oil than some of these countries. Because even to walk half a kilometer, what do we use? We use a three-wheeler or a car. And we never think of using a bicycle. So Sri Lanka is another country that is suffering a lot. Not because we don't have dollars, but we don't know how to use the dollars well. So Sri Lanka is in one country that we have got everything messed up because we have not adopted the correct policies. So if you look at the correct policies for a country, correct policies, we need expressways. In this context, we are okay. We need highways. That means A and B class roads. Here also we are okay. We need red runs. What are red runs? They are the small roads that will interconnect all these other roads. So any road that connects, any small road of 3 meter width, 3 meter or wider is a red run. So 3 to 6 meter road that connects two other roads is a red run. It can be local road, but it's a red run. Why? Any local road can attract local traffic. Now these days, because of Google, they attract long distance traffic as well. But generally, in Sri Lankan context, long distance drivers don't like these Google based traffic guidelines because sometimes, they take you in roads that are very narrow, that are not, just to save time, they take you in the wrong roads. So because of that, many drivers don't like, long distance drivers don't like the Google guidance. So basically, we are okay. Then you have to see what is not okay, not satisfactory. Because if you understand the problem, only we can find the solutions. Because most of the time we try to find the solutions without understanding the problem, and then you find the solution is not up to the mark. So I'm trying to tell you about the problem first. Then we'll understand how to solve it. So I have told you half the story. That is, we are having a huge problem with concrete, huge problem with steel reinforcement, huge problem with shuttering. The shuttering private costs are very high. So unless you go for steel shuttering, then you are not. And even steel shuttering is also very expensive because steel is very expensive. So we are having a big problem, right? But not satisfactory. We have 1 million three-wheelers. We have 4 million scooters, motorcycles. we have 1 million cars, and we also have 1 million diesel vehicles. Now out of this lot, and I think now we are getting many bicycles as well. We really don't know the number. We really don't know the number, but I'm sure that we are getting many bicycles because we have about 6 million houses, and I'm sure now we'll be getting many cycles, at least one bicycle in every house. But if you look at a country like Holland, which is very much into the bicycles, so the number of bicycles is about 2 times the population. So I cannot remember the exact population, but it's more than the population. So the number of bikes available in that country is more than the population. And our number maybe, I'm sure it's less than the population. Then if you want to see how Cuba faced this problem in 1990 when Russia, under the leadership of President Gorbachev, allowed Russia to break up. Maybe another American initiative, we really don't know. Whatever it is, all the countries that were under the Russian control were allowed to be free, including East Germany. So in the world map, this is America, and Cuba is here, Russia is here, India is here, and Africa is here, and then you get the Europe here. So Russians could not control. So what happened was, Russians used to send a lot of oil to this country, Cuba, and Cuba was at the very doorstep of America. So Russia liked to maintain Cuba, but Gorbachev was also different. He was not interested in that type of policy. He wanted to, make things easier and to end the Cold War. So Russia made smaller, became smaller, and they could not get oil from Cuba. So Fidel Castro was a wise man. He imported, Cuba has a small population. He imported 3 million bicycles from China. And China and both China and Russia, China's here, Russia, they are both communist countries, but China has Chinese communism and Russians have Russian communism. So although both countries talk about communism, they are very different. So Russians don't like Chinese communism and Chinese don't like Russian communism, but now they are becoming more and more friendly. So these two countries are becoming friendly. And so Europe is there. Europe is more USA based now. So these are the things that we have to understand. So basically they imported 3 million bicycles from China because China was willing to help these people. And what they did was, your house is here, your factory is here. Then they said, okay, you can go to the factory here. So you travel only this. You don't travel all this distance. So they allow people to change the workplaces so that you work very close to your home. And that way, nobody in Cuba felt any problem, and very few vehicles on roads. So roads become safe for cyclists, and also people became healthier. because there's something called body mass index, which is weight divided by height, say 1.7 square. So you calculate it, and this must be between 18 to 20, 25. You are okay. If it is more than 25, you are not okay. If I ask many in the audience, what is your body mass index? And if I ask you to calculate it, I'm sure for Sri Lankans who eat a lot of rice, generally the body mass index is between 25 to 30, which is a slightly risky range. And the risk increases as you age, as you reach 50 and above. And today I was told that one road development authority engineer died while waiting in the petrol queue. He was 55 years of age and he died of a heart attack. Now you will ask why. The reason is you have not maintained your body mass index between 20, and if it is greater than 30, then you are high risk group. So calculate it and see. Then you will ask, how do you bring it within the range? And it is easy. You get up at 4 o'clock or 5 o'clock. By 5:30 to 6, you go out, 4-kilometer walk with empty stomach. And why I ask you to get up early in the morning is, if you get up early in the morning and do some useful work, even office work or whatever, because most of you are working from home, if you do some office work at this time, you will find your work is super efficient. So it's because a lot of people are working from home. If you want to make the maximum out of your working hours for your office, get up around 5 o'clock in the morning, and then work 1 hour, 2 hours do your office work there. You'll find your brain works like hell. So you go walk 4 kilometers, and then you get into a cycle and cycle 30 minutes. And or else, if you are interested in yoga exercises, try yoga for 45 to 1 hour, 60 minutes. So this is the first part, walking. The second part, it can be either cycling or yoga. Both will help you to improve your blood circulation, the bone mass, bone weight, the strength of the bones, the strength of the muscles, everything will be improved. And you will become slim, and gradually you can start reaching from 35 to 30 plus to 30. And then you can increase from 30, reduce from 30 to 25 range. And if you are in the range of 23 to 24 as a male, or 22 to 23 as a female, then you are okay, pretty okay. And then, so what you do is, after that, go for a light meal. Because in Sri Lanka, we used to have only one major meal. And what happened was, in 1940s, after the Second World War, we started getting free rice, and we exported tea, and we imported a lot of rice, and our people gradually started to eat 3 meals: breakfast, lunch, and dinner. And the maximum calorie intake should be 2,000, whereas our people used to eat 2,500 to 3,000 as the calorie intake. And because of that, we developed people who look like with a fat belly. And you can see, you can look at Chinese, you can look at Japanese, you can look at many people from UK, but Americans are very different because they eat too much. They have a problem. But many people from UK, Japan, Australians also eat too much. But many people who are doing pretty, or Germans, many Germans are doing well, but some others are not doing well. So basically, if you consume anything more than 2000 calories, you ask for trouble. And you can see our rice intake in Sri Lanka is 107 kilograms average per person, and we should actually bring it down to about 60 to 80. The day that we do that, we will not have any. Most of the health problems can be very easily solved the moment you bring down the body mass index. Now you will ask why it is relevant. Because it's very relevant, because for you to do value engineering, what do you need? You need a super powerful brain. Super brain. Because there are so many parameters to look for. Unless you have a super brain, you cannot figure out how each parameter is related to another. So because of that, you need a super brain. You get a super brain. All the Sri Lankans are having a wonderful brain. They are very intelligent. But your brain power can be used only if your stomach is empty. It is empty. If your stomach is empty or just filled with little food, then your brain can become super brain, because we have so many parameters to look for. So what is the easy way out taken by our engineers? They simply copy from earlier designs. And this happens all the time. And if you have one mistake, then it will be repeated in all the subsequent designs. And one good example is STDP project. That was planned in 1990s, late 1990s, under the President Chandrika Bandarana Kumaratunga government. Then it was the project, the ADB approved the project in 2003, and then the Prime Minister was Ranil Wickremesinghe. And then CECB was involved in the designs. I'm trying to show you how we can get things wrong, unless you are very vigilant. So the CECB is mainly a building engineering, so they are good in buildings. So they did not have enough expertise in bridges, but the engineers thought, okay, I am a good building engineer, I can be a bridge engineer. It's very wrong. Why? Bridges conditions are very different and our thinking is very different. That is what you have to get right. So they thought we can have piles, and then there was another guy called Engineer Chan, and a Malaysian-born Indian, and he also did not have much experience, but he pretended he knows the subject. Now this is our biggest problem. If you don't know, say don't know. Never say I know when you don't know. So they put battered piles. Battered piles. And use of battered piles is very wrong. Why? Not for static. Static forces, battered piles are okay, but dynamic, if you get earthquakes, dynamic forces, battered piles fail. The moment the battered pile that is used for stability fails, what will happen to the bridge? The foundation will start moving this way. And because the foundation is moving, what will happen? Now the foundation is moving, bridge can collapse. So the bridges with battered piles collapse in an earthquake. And we have built an expressway lasting 120 years at least. We actually expect it to last 200, 300 years, but at least 120 years. Because even it's all of our cars to go to Mathura, we need an express. So we are designing expressway with a wrong concept. What is the correct concept? I don't know who developed this concept. Correct concept is board piles. Board piles. The correct concept. And then this precast piles is wrong again. Why? Because these can be in reverse. Reverse, we get scouring. Removal of this material. And if the bridge is not anchored to the bedrock, what will happen? The bridge can be washed away. Just imagine washing away of a big bridge in the major highway like Southern Highway, which has Ginganga crossing, which has Kaluganga crossing. All these crossings, the bridges are mostly on precast piles. Some may be having board piles, but most of the bridges are on precast piles. I mean, I have checked some of the bridges when the major problem occurred. And now let's look at the major problem. Now again, that's another blunder. So when you learn the blunders, then it's easier to come up with a good value engineering solution. Otherwise, you might come up with a cheap solution, but it may have a lot of blunders, which is wrong. So major problems. Now what is one of the biggest problems with big pile caps? If this is about 1.5 meters deep, what is the problem? DEF, that is delayed ettringite formation. Delayed ettringite formation. What will happen? If you have delayed ettringite formation means in the center part of this temperature goes above 70 degrees, then what will happen? The reaction of C3A tricalcium aluminate plus H2O will form a chemical substance which is stable. But if the temperature has to be less than 70 degrees for this to be stable. And this is the one that gives strength from 1 hour to 24 hours. And it is responsible for about 10% of strength. Because you get only about 8% C3A. So this can give about 10% of the strength of concrete. And once form is stable, if the temperature is less than 70. So here what happens is, if you don't control the temperature, in the core area, temperature can rise above 70 degrees. So what happens? Then the reaction goes in the other direction. Now the reaction that went this way initially, now will reverse. So now the material is this one. And if you do not provide a lot of reinforcement in the pile cap, what will happen is pile will develop minor cracks. And through these minor cracks, water will come here. And as the water comes, what will happen? Now this reaction will again start. But this reaction in the first 24 hours is very much okay because concrete is weak and it's shrinking due to the evaporation of water. And C3A plus H2O has a higher volume than C3A. So what happens is, in weak concrete, it's shrinking, and this will expand. So shrinkage plus expansion, not bad. And concrete can accommodate it because concrete is still weak. There's no strength. So all these movements can be very well accommodated by concrete. So concrete you will find, though it shrinks, you cannot see the shrinkage very much. So it looks like the concrete is there intact. But what happens is it has shrinkage has occurred, so has the expansion. So what will happen? Now this guy is expanding and is exerting pressure in every direction. And unless you have a lot of reinforcement, what will happen? These cracks, these expansion, the force of expansion is sufficient to crack it like hell. And it will crack. Unbelievable cracking. So most of the bridges, so if I tell you about Southern Highway, so this is what happened in the highway. So because it's so important for us to know the history. And when you know the history, you will not make mistakes. When you don't know the history, you make mistakes, and then somebody will say, oh, you are a fool. Because this, you should know this. As an experienced engineer, you should know what happened in the past. So what happened is, this is Sri Lanka, and this Kottawa, this Gaul, this Math. This is Mattal. So we had no intention of doing it for Mattal initially. But we planned this one about 10 kilometers inland. Then you will ask why? Because those days philosophy was no house damage. So select paddy fields. So the instruction given was select paddy fields and run the highway across paddy fields and have links to the highway from many places, so that every interchange will have a link to the major town. So we have link to Panadura, we have link to Colombo, at Kottawa, Panadura, Casbaba. So that is the Casbaba intake, exchange at Kahatudua, and then Panadura is at Galanigama. And then we have Kalutara at Dorangoda. Then we have Matugama at Matugama Kalutara at Dorangoda. Then we have Alutgama at Valipanna. Then we have Ambalangoda at Kurundugahatemme. And after that we have Hikkadua at Hikkadu, Baddegama. And we have Gaul at Pinnadu. So those are the only exchanges. And after that we have about 3 more. One at Veligam and 2 other cities. So we have up to Matara, Godagama, we have exchange. And then we have another about 5 or 6 when we go up to Matara. So you can see it's a very well planned highway, and we have connections to all this. And the concept of central highway was very different, because people started shouting and they said, we want our highway going through our city. So it goes to Mirigama. It goes from Kadota, Mirigama, and to Kurunegala. It goes to town. Whereas the concept of first highway, STDP, Southern Highway, was very different. And it never went through the towns. It went away from the towns. And basically the structures were all in, it has to cross every river that goes. So Ginganga, so there are so many other rivers. So all those rivers mean a lot of bridges. And then because it was on a low-lying area, so it was on an embankment. So it was like this. But when you have an embankment for the highway, you have to make sure people can cross from one side to the other. So people can cross from one side to the other. So we have people crossing and the vehicles also crossing. So which means you need lots of culverts. So the initial team decided, okay, we are going to have a strange structure. That means like a 6 to 8 millimeter thick steel. And it's a corrugated steel like this. It's a corrugated steel. So it's a corrugated steel going this way. So there are corrugations like that. So this corrugation is like this, going like that, corrugated. And then use compact soil gradually. And then the structure can be easily constructed. But these are not meant for expressways. So all our highways are undertaken by Ministry of Highways. Ministry of Highways. The expressways are constructed by Ministry of Highways, because they are constructed by international contractors. So Ministry of Highways handle, but for management, they get engineers from RDA. So RDA from the ministry will ask for many engineers, senior engineers, and senior engineers from RDA will become the people who are actually managing the project, because the administrative officers of our ministry cannot manage the project. So they don't know how to manage a project of this scale. So so we have page number 1, 2, 3, 4, 5, 6, 5, 6, 5, 6, 7, 8. So this page number 9. Page number 9, 7, 2020. Right. So basically, this was sent to RDA designer for opinion. And then there was one tough engineer called Engineer Nima Chansiri. He did not know anything about this type of structures because they actually came from the design engineers, but he's a guy who never gives up. He's one of the brilliant engineers we ever had, and he went through the literature, collected literature, and he found that these are not meant for expressways. These are actually meant for some not so important roads. So he protested, and after that, these were never sent to him. So he was out. So he was not sent. So his comments are not taken. So this was in 1999, 1998 or 1997. So that is a long time. Then in 2003, they started constructing this one. And because of the inexperience of CCB engineers, they never bothered of DEF. So that is one mistake. So we have to be very careful. Because when you go for value engineering solutions, you also can do these blunders. If you don't know, what can go wrong? Because in value engineering, we are actually trying to do things differently. So if you are trying to do things differently, then you must know how things can go wrong. Otherwise, you will do blunders. And then no value engineering, because now to correct the blunders, you might need to spend more money than you ever saved. Right? So you have to be very careful. So they went for this. They found that. So they did not bother. So because these piles, now you know, when you have pile cap, say this is the wall 1 meter wide. So all these loads that are coming through this will go through this way, and this will be going to tension. This will go into tension. So what we do is we calculate this tension and then provide reinforcement like this. And then we also look for the minimum reinforcement based on the full height, minimum reinforcement, 0.13%. Minimum reinforcement is also provided. Because we know things can go wrong in a pile cap, especially when it is thick. Because we might not control the DF very well, but generally when you provide a lot of reinforcement, this problem will not occur. Now, due to the inexperience of the CCB engineers who got all these battered piles and all those things, wrong concepts, we had a lot of piles, precast piles. So when you have a lot of precast piles, when the load is coming from above, then you will find, the load can go in every direction. And the effect of load transfer is not very pronounced because we have so many piles, so the reinforcement can be reduced. So they use some unknown theory. Actually, I tried to understand, I could not understand. So it's an unknown theory. Unknown theory, and they actually reduce the reinforcement to such an extent. Even the subsequent reports, all the consultants said pile caps are very likely are very all these reports are available in RDA. So caps are very lightly red. I also had all these reports because, so I'll tell the story now. So when this was planned, like this, from here to here, it's a 4-lane highway. And to Matara, 2-lane. So this portion was given to ADB, was funded by ADB, and the contract was Kumagai. Kumagai was the contract. Kumagai Gumi. And the concern was Roughton, and another Wilbur Smith or something, some company was there, but you know, they were later blacklisted because later ADB found that that particular company has taken a bribe from, or given a bribe, or taken a bribe, or something from in another contract in another country. So the moment ADB found that, you know, some corruption was involved, they blacklisted that company, and later only Roughton was there. Only Roughton was there. That is called Wilbur Smith or something. I can't remember the exact name. So they were blacklisted, and if you go to internet, you can actually find who was there and who was blacklisted and what is the reason. So if you type the blacklisting of Wilbur Smith, you can get all the details on the internet, right? So what happened was, so that is, and then this section was funded by JICA, and they got two companies. One is CESC, and you know CESC is very well known these days because one minister has asked for a bribe from CESC. CESC is a good Japanese company, and then the next part was China. China Harbour was from Dorangad to Kurundugahatam was by China Harbour. Kottawa to Dorangad was from, that is Kadutara Exchange, was by CESC, and it was all funded by JICA. And you'll ask how I know all these details. One thing is, most of these details are available on internet. But anyway, some incident happened in October 2009. So actually, this project started in 2003. It went well, 2000 until about 2006. Then things started to get, you know, then they changed the project. So this was from Kottawa. Here you get Kurundu Kahatamme, and then here you get Gold, here you get Martha. So Kumagai was the first company started, and they did a 2-lane project very well up to Martha. By around 2006-2007, the project was almost there. Then suddenly the wisdom came. They thought, okay, why are we constructing a 2-lane highway with a shoulder, with a hard shoulder? So it was like a highway like this, the hard shoulder, this is the highway, this is the highway, this is the hard shoulder. Why not make it a little wider? Why not make it small area, lane, center median, lane, and small thing. So you need only to widen it by only 6 meters. So when you widen it by 6 meters, now you can convert the 2-lane with hard shoulder to 4-lane. So you need to extend it only by 6 meters or 8 meters. Then they found, oh, why are we doing such a blunder? Because having a 2-lane highway is a blunder. You can easily convert it to a 4-lane. So these people, Kumagai was said, okay, you don't have to worry about Gol Mathara, you forget about that area. Now you make it 4-lane. So Kumagai started making it 2-lane, 4-lane. And by 2008, the war was going on at full swing, and we were getting very bad reports about STDP project. With lot of corruption, theft, lot of bad reports are there. From time to time, we used to hear a lot of bad reports about that, and we heard that it's not properly managed by the ministry team, who is actually the engineers from RB and so on. Lot of problems were there. And then we also heard that private buses of Mathugam LPT area, they all run on diesel, taken out from various machinery and all that. So there's so many bad stories about that. And in 2009 October, when two boys were crossing, they were doing some repair, and the Japanese engineer was told, okay, remove the soil on both sides. And that high-handed engineer, that's why, as I say, when you are doing value engineering, you have to be very careful. Without listening to all this, he removed all this soil. He did not understand the arch theory. So, and in that night, it rained a lot. And two boys are crossing. And, this is a classic way of dying. So one boy walked past, the other boy was having a phone. He got a phone call. He stopped to answer the phone. And this boy kept on going. And as soon as he reaches here, this guy is here, discouraged. Because soil has been made saturated by the rain. And soil weight becomes too much. Soil became weak. The C and 5 parameters were changed due to the presence of water, and soil lost strength. Too much weight came onto these very weak, thin shell type structures, and it all collapsed. And the boy was killed. Unfortunately, he was killed. And then the villagers who were very angry with STDP started writing. So it was like another Aragale there. They would start writing. Then the government thought, okay, we are not going to go any further with this project. We need a presidential commission so that, they can divert the attention. And then I was appointed as the chairman of this one. And we started investigating. And the coordinating engineer was Engineer Chandrasiri. So coordinating engineer was Mr. Chandrasiri, and then what happened was, Mr. Chandrasiri gave me all the files that he had in 1997, 1998 on these structures. And I started investigating, but I had no idea about these structures because I have never seen such structures, because I never considered they are suitable for any expressway project, not even a highway I would consider. Because they were made for America, where the labor is so expensive, and so steel structures were actually meant for American market, where the labor is very expensive. So if the labor is very expensive, constructing a structure like this by filling up with soil is very cheap, very, very cost effective. So it was a structure meant for America, and then there's some H-beam, and there were a lot of cracks in H-beams as well. So these were, the moment you look at these structures, you can see they are very poorly constructed structures. So there were a lot of criticism about those structures. And I found that there's a blunder. What is the blunder? There's a theory that says the minimum cover is 600 millimeters if rigid pavement. Pavement is rigid. If the pavement is flexible, you have this 600 plus the thickness of the flexible pavement, which is about 600, another 600 millimeters. Because in a flexible pavement, you get base courses, then ABC, then premix, and then the wearing course. So altogether will be about 600 millimeters. And then you need to have another 600 millimeters of soil. Now, suddenly we found that, the designs are wrong. Designs are wrong. So here for the major STDP project, designs are wrong. What will happen? So if they are wrong, you have to correct it. So the correction is have a concrete line and make it a concrete arch. Forget about this. And we try to get it done by the contractor, but contractor quoted very huge prices. So we found that it's not possible to get it done from the contractor. So at the Department of Civil Engineering, University of Moratuwa, we designed all these shells, that all the details are, all the reports are available. I think about 80 reports we did. And for every structure we did a report with a complete finite element analysis. Using, those days we used SAP because we were actually looking at the equilibrium condition, which is, although SAP is not strictly applicable to the behavior of soil, we were actually looking at the concrete part, not the soil behavior, but we were just looking at the forces and what the forces that will act on concrete. So the use of SAP 2000 for that type of analysis can be justified. So when the other thing that you have to understand is the soil behavior must be represented by a soil software, and don't do SAP 2000 if you are trying to model soil. If you are going to find the deformation of short-term deformation of soil, yes, SAP 2000 can do that. But if you are going to find the long-term, the real soil behavior, you must go to a geotechnical engineer. So my favorite is Dr. Nalin Silva. The reason is, I know he knows the theory. There are many others who pretend that they know the theory, but when you go to them, you don't get a good service because they don't know. And his number is 0755494977. So I trust him because he knows the theory. So basically, it's so important that you must know what the theory you need for analysis. If you don't know the theory and then use some software, you will get answer. So we say garbage in to the computer, and what do you get? Garbage out. So you make a raw model, analyze, and then you get wrong answers. You design, and then the factor of safety can become less than 1. One day it collapses, kill people, as it happened in Miami about 1 year ago. About 1 year ago, I think, in Miami, one building collapsed, about 15-story building, and that was because the design engineers have underdesigned the transfer plate. Because when you underdesign it's so easy to underdesign a transfer plate, because if you just consider it as just a plate, then you can underdesign it. But if you consider that it's a plate loaded with incremental loading, then you will find the bending moments can increase by about 30%, whereas shear forces can increase by about 10%. So if you don't know that theory, then you can easily make a big blunder. And my rule of thumb is, increase the bending moment by 50%, increase the shear force by 25%. Why? This is such an important structure. If you provide little more reinforcement in a transfer plate, it's no problem, because transfer plate, if it is good, if it is having a factor of safety of 3, then the usual factor of 2 or 2.5. Because when you design a concrete structure, the normal factor of safety is 2 to 2.5. That means you can overload it by 20 to around about 100% overloading can be taken up by the structure before it reaches ultimate limit state. Whereas I would like it to be about 200% overloading for a transfer plate, because transfer plate is a key member. So when you are doing structure designs, you must understand There are some members that are considered as key members, and a failure of a key member is a killer. Can kill. It can kill people. So key members must be over-designed. It's not a crime to over-design a key member, because it's a crime to design the key member, because if you design the key member, there's a chance one day key member might fail, lead into a catastrophic failure of the structure. Whereas if you over-design the key member, there's absolutely no chance of any catastrophe like that happening, because key member lifespan will be much longer than the lifespan of the building. So the key member will hold the building, whereas many others may have many durability problems and repairs may be affected, but the key member or the transplate might stay without any problem. So you have to actually get that right. Okay. So then there was a query, and then we found a lot of problems. So we suggested this. Still, unfortunately, if there are engineers from RDA, they should look into this matter, because we gained about 5 billion rupees from this STDP project. Now I think it may be about 6 billion rupees income per year, and we need, if we do 1 billion rupee worth of repair every year, after 6 to 7 years, you'll find all these structures can be repaired, because it's just pumping concrete with some reinforcement and forming a skin which can act as an arch for this box, for this gird. So basically, it's something that should be done, because it's a design fault. So when you have a design fault, you have to manage that, correct it. But unfortunately, in our southern highway, it is yet to be corrected from Kurunduga Hetemme to Mata. So though we are talking big about our highway, it is having design faults from Kurunduga Hetemme to Matara, especially with these soil style structures. So after that, we opened the highway in November 2011, and about around that time, the government of Sri Lanka decided, okay, it is wonderful to have a highway up to Ball, but to get the real benefit, it should go up to Matara. Right? So it should go up to Matara. So a fresh contract was given to a Chinese company, not very professional, but they don't have proper manpower and work ethics. But the consultant was the top man was the engineer MBS Fernando, and he was the first chairman of I think he was a chairman, yes, chairman of road development. He was the first chairman of Road Development Authority. He actually came from Highways Department. Many engineers did not come to Road Development Authority from Highways Department, but later they were forced to come. By that time they came. The first people who first went were very senior, and they were the general managers and chairman of RDA. So that's what happened. And this change happened in 1985. 1st January 1985, RDA was created. And before that, it was the highway department. It was a highway department. So I went for training in November 1985-84. We went for the training at Highways Department, and by the time we finished our training in January 1985, December. So early December, and when we finished our training somewhere around February, we had only about 10 weeks of training. Somewhere in February 1985, we were actually theoretically we were attached to highways, but we should have been attached to road development, because highways department and road development authority existed side by side for a while, and after that gradually government made sure highways department becomes nobody and road development authority becomes the authority. So it took about 1 year, and then so basically Miss MD was there, Nimal Chandrasiri was the coordinating, the project director appointed by the Ministry of Highways on secondment from Road Development Authority. And he's a superb client's project manager. And when you are client's project manager in a design and build project, how do you avoid claims? Build project. Now the most important thing is avoid claims, because you have told everything you want to tell. You basically, when the contractor is preparing the documents, you have to make sure 100% of the things you want are clearly said, so that if there's anything that the contractor does not provide you for the stipulated price, then you can force the contractor to fulfill it, because in the original document you have included all these requirements. The original requirement they have used for bidding has all the requirements, and because of that reason, you can claim, ask the contractor to do it, but contractor cannot submit it. So that is one of the very important project management principles. So how you avoid turnkey projects or design and build projects? Design and build projects. How you avoid claims is, do not tell the contractor what to do. Once started, if you tell anything, contractor will happily say, yes, sir, we'll do that, no problem. But after about 2 months, now you find for something that you would have cost 10 million, contractor is claiming 50 million rupees. So now you are in a fix, because you have asked the contractor to go ahead without knowing how much he is going to claim. And because of that reason, contractor has properly done the job that you have asked the contractor to do. But now you are expecting the contractor to ask for 10 million. Contractor is asking for 50 million rupees. So you are in a fix. So the theory is, you must prepare the project brief, taking sufficient time, so that, and it should be done by a proper expert. Hire a proper expert and get it done, so that contractor can be left alone. Then you'll ask, what the hell these clients engineers are doing? They have plenty of work. So the contractor submit bills, they have to check the bills, they have to check everything. So basically, the client's engineer has to do a lot of work, and that is mainly on checking. But if you see some mistake, some omission, so that means your original document has it, but contractor has not done it. The original document has the task, but contractor has not done it. Now suddenly you become a king. And what you do is, you fire a letter to consultant and don't do anything. If the consultant does not take proper action, you can raise it at monthly meeting. Monthly meeting, you will ask why the contractor, we have shown a shortcoming that we thought as a shortcoming. We really don't know if it's a shortcoming or whatever it is. We showed that there's something in some disparity that we have observed, because when we carefully looked at this particular set of documents that is actually used as the original set of documents, we can clearly see you have omitted. So the theory is, keep your mouth shut. mouth shut, but be a spy and find what contractor did not do, but in the original document. You may don't work on your mind the requirements. If something is not included in the original document, you cannot ask for it. Never ask for it from the contractor. If the moment you ask for it, the contractor will submit a claim. So we must be very careful in project management. Project management is an art, and our engineer Chansiri did it so well. And you won't believe there's 36 kilometers from Galle to Makara. And you will ask, what is the distance on our normal road? Normal road is 28 miles, and you can convert 28 miles to kilometers. And Galle Makara is 28 miles into 1.6. Makara is 100 kilometers, 100 miles. Galle is 72 miles, so it's 28 miles, so 44.8 kilometers. And you can see Southern Highway, because it goes inside the country. It goes inside, and also it's a straight road, not a winding road. The normal highway has 44.8 kilometers, whereas the length of the super expressway is 36 kilometers. And you won't believe this 36 kilometers be widened for 4,000 million rupees. So this is the embankment. So we made it slightly wider. We did not have to cut any hills, because when the original contract, if you are cutting a hill, you cut for 6 lanes, because one day this highway will be a 6-lane highway. So provision is therefore this to be a 6-lane highway. So Southern Highway can be a 6-lane highway one day if the demand is so much, because at the moment there's no demand for that kind of expansion. But had it been the previous government that was there before 2014, end of 2014, they would have actually widened the Southern Highway to be a 6-lane road as well. So because they were so fond of doing things that we really don't know. So basically, this is a project that started in 1999 under the Chandrika Bandana Kumaratunga, awarded under Ranil Wickramasinghe's time, but still she was the president. And then they found that it is not happening when Mahinda Rajapaksa was the president. And then, we actually did a lot of work to rectify this. And then, so our Department of Civil Engineering, another professor was asked, find whether it's really DEF, and the report came as inconclusive. So they did not know whether it's DEF or not. So then what it thought was, okay, so whether it's DEF or not, we have to repair it. So we had a big fight with the consultants that they hired from UK, and so we actually sorted it out. So basically, you can see now, if you are doing for value engineering, you must be very careful about DEF, and you must be very careful about concrete strength, whether you use PT, and whether you have provided the minimum reinforcement. That's another hassle, because concrete, we have to provide minimum reinforcement when you are doing a bridge. So in 2010, Engineer Nimal Chandasiri was made the project director. And during that time, there was a change in the ministry. So Admiral Vasanta Karanagoda became the secretary of the ministry. And he did a very good service. He was very friendly with us, and we all worked. So there's a team, MTRJ, Vasanta Karanagoda, BVD and Chandasiri. So that was the main team. because we had to clear the blunders. And blunders are design blunders. Blunders and quality controlling blunders. That is not taking enough precautions to prevent DEF. So there were so many blunders in this project. And by the time we stepped in, all the blunders have already done by inexperienced engineers who did not know that they don't know. So it's very important when you are doing value engineering, you must know the subject well and also know what you don't know. Do not know. That is also very important. If you don't know anything, so for example, if I have to do a geotechnical design, I will not do it. I will ask Dr. Narendra Sidla to use MIDAS GTX or MIDAS SoilWorks and ask him to ask Dr. Narendra Sidla to. He's a young guy. He passed out in not very young, but he's very experienced. He has MSc, PhD, and working experience in UK experience, working experience. So, and he's a real brain, and he's a master of the game. And I think he gets up very early in the morning and work. That's why he's such a good brain, because when you get up early in the morning, it works. So you must know. That means you must read Euro codes, and you must read it fully. Right. So that is the way that you do value engineering. So you must learn every bit of Euro code, but Euro code is a very complicated document. So what I do is, when I read, I convert it to a simple rule that I can remember. The real domain can be like this, but you will find if you know this part of the knowledge, then you can make correct decisions. So what I do is, by reading all these things, I eliminate all the unnecessary things and I select this part of the knowledge. And then what I do is I convert it to simple rules. So if you ask me to do a highway design, I need minimum reference of Eurocode 2. That is with highway. Why? The reason is, I have already stored almost all the rules that you have to know in the brain. So it's very important if you are going to be a value engineer. You have to work hard. You cannot be a value engineer based on experience, because value engineering is an art that must be learned by the engineer by improving the knowledge to the level that the engineer can almost do a design without looking at a code. So that's the level of knowledge you need to have. Now you know the problem. No materials, expensive materials. There's a need to minimize the use of materials. Why? If the material content is minimized, then the cost goes down. Why? Automatically you are using less material. So how do you use less material? How we use less material is, we go for high strength concrete. Because the beauty of Euro codes is, they allow you to use concrete cube strengths from 30 up to 105. The cube strengths can vary between preferably 30 to 105. So that is the condition that is. Whereas in Euro BS codes, generally, we go for something like 30 to 25 to 50. So our range is about 25 to 50 megapascal. Whereas when you are using Euro codes, you can go from 30 to 105. Now let's see What are the advantages we can gain by going for high strength concrete? So to do that, we are going to look at an example again. So this is one possible solution. And I girders is one possible solution. So that's one possible solution you have thought because you are a traditional thinker. Then I come in, I say, okay, I'm going to do it different. I'm going to do this. And I'm going to have this. And I'm going to have four large piles. 4 numbers of large piles. I'm not going to have a lot of piles and huge thing. But I'm now going to cantilever this about 6 meters. How do you have a cantilever of 6 meters? That is not easy because you have to have some reinforcement going like that and some other reinforcement going like that. And this is called two-stage pre-stressing because, and then rather than have so many beams, I'm going to have 3 beams. And this is 18.2 meters. So I'll have three beams. And the bearing costs and other bearings. Okay. Now which one will cost less, cost more? So this may have 18 meters means this may have about 10 I-beams. That means it's going to have about 10 webs. 10 webs. 10 I-beams, 10 webs. How many webs that I have here? I have only 6 webs. This might need about 10 piles because you have to support it every. I am using only 4 piles. And here you have huge quantity of reinforcement going in. Here I have a very narrow thing which is only about 4.5 meters. So I need less concrete. And then I also need less concrete and I need less steel because concrete, when you put concrete you have to put a lot of steel. So basically now you can see how I'm thinking about it. And so I might have about 30 to 40%. But my intention is to go for 50% or even more. Then I might do another design. What is that? I might go for a cellular raft. So I remove a lot of soil because about 3 meters below, I have found that around 5 meters below, the soil is good. It's lateral. So if it's a lateral soil, why do you need a pipe found here? Where the pipe goes up to 30 meters. You don't need it. I'm going to go for a cellular raft. And I will make it very, the soil weight replaced by the raft, cellular raft, is equal to the total weight of the bridge. Then what will happen? Will the soil know that, something has happened? No. Because earlier soil was supported lighter. And then I'm going to have a bridge on top of that. And in that bridge also, rather than having a lot of reinforcement, I'm going to use 60 megapascal concrete and put some vertical pre-stress. So what will happen when you put some vertical pre-stress? What will happen? So what happens is, when you have high strength concrete and put little bit of pre-stress, what will happen? When this goes try to go this way, anyway it's carrying a lot of compression. And if a bending moment comes, this will become active, this will not be active. It has huge strength. And because it is pre-stressed this way, is there any chance that it will crack like this? No, it will not crack like that. So what you do is, you'll provide a very minimum amount of reinforcement. And also, sometimes you might consider that, if you need a wide, you go for a wide capping beam, wide one, where you can make even the center part hollow. What is the advantage? Because this is having 1200 width. So what will happen? You need less reinforcement. That's one. Because you have high strength concrete, so you might use 10 millimeter reinforcement just to control the cracks. Because concrete cracks, so you have to prevent cracking. So you provide little reinforcement. Is there any chance of DF here? You cannot have DF in here, so you don't get DF. Because it's a big pore, then you can get DF. Now you are not getting DF. So that means everything you say, everything that you can think of saving, save. And then, because now we are not going for pipe foundation, we are going for a hollow pier, and then we are having a solid pier capping beam, and pier capping beam has a very narrow support, and pier capping beam is relying fully on pre-stressing. Because it's relying on pre-stressing, it's very much worthwhile having some pre-stress there, because we can create very unbalanced situations during the construction. So you go for that. So basically, you will use very high strength concrete that will allow compression members to be apply PT. So basically, you are having a member in compression, you are applying PT at the two corners. What will happen? But you are having some reinforcement there, very lightly reinforced. You don't need reinforcement because PT has so much capacity. Whenever something happens, PT will make sure the structure is brought back to its original position, unless you have permanent deformation, which is very unlikely. So what you do is, you will go for PT, high strength concrete. Why? Because the Eurocode allows you to go for 0.6 FCK. And FCK is the cylinder strength. The FCK is the cylinder strength. For example, when the cube strength is, the cylinder strength is 25, cube is 30. The cube is 30. Because cube always shows about 25% extra strength. The strength you see in a cube is not there. It is just an arbitrary thing, and it's not there. It is actually the cylinder strength is the accurate strength, whereas cube strength is not accurate. It's showing a higher strength than the normal. So you must know all these things. Then you can easily go. Now you can see, after explaining all those unnecessary things, where I told you so many things, suddenly I have shown you how to optimize. Because now I'm thinking about 60 to 80 megapascal concrete. Then you'll ask, how on earth you get 80 megapascal? And I did not say I'm going to get 80 megapascal in 28 days. I will try and get about 50 megapascal in 28 days. And then what I do is, I will use fly ash 50 to 55 megapascal. And I will have a strength development curve like this, which is a gradual one but continuing. And if I don't use fly ash in today's cement, it will go like this. So this is without fly ash with today's cements. And what is the difference between today's cement and the earlier cements? So this is 40 years ago, and today, so we have the main item, tricalcium silicate. 40 years ago it's 50, now it's 60. Dicalcium silicate, which is responsible for stent development from 14 days until infinity. Those days we had 25%, now we have 5%. And C3A content and tricalcium aluminate content was used to be 8%. Today also 8%, because if you mess up with that, your concrete can crack later. And then C4 aluminum ferrites, it's about 10%. Even today, C4 aluminum ferrites remain as 10. So basically, you can see cement is different. So the only way now, this is 1 to 14 days. So this is very hard to make sure the strength gains after 14 days, because this is only 5%. So what you do is, when you get concrete cement, so if you want 300 kilograms of cement, you go for 260 kilograms of cement and 40 kilograms of fly. You go for 40 kilograms of fly. So the moment you go for 40 kilograms of fly ash, now you have a cement which is capable of doing this, which is capable of doing this. Whereas if you use 300 kilograms, then it is capable of doing only this. So if I am having a cement that is capable of going on this, if I have achieved 55 megapascal in 28 days, in about 1 year, what will happen? I will have 80 megapascal. So how long will you need to complete the bridge? Because let's say it's about 40 meters spans, 10 spans. The long bridge, big bridge. So it needs about 1 year to complete. So if you are getting this high strength in 1 year's time, it's perfectly okay. Perfectly okay. So what we do is, we go for some logical thinking based designs where we start stretching the clauses given in the code to the very limit, because Euro code never asks you to rely on 28-day strength as in the British code. So you can see, you can go for strengths which are achieved a much later date, but still you can design, when you are designing the transfer state, transfer 40 megapascal, service 80 megapascal. So no problem. The transfer is not very important, because the transfer stresses may not be that critical. Whereas what is most critical may be the durability concerns. Durability, because you are using very high strength concrete, the code might allow you to use a smaller cover. And when you use the smaller cover, you can reduce the concrete. Because you are using smaller cover, so your concrete quantity will come down. So when you do all these things, you might hit something like 55 to 60% saving. And we call it value engineering, because a road can cost about 2 million US dollars per kilometer. 20. A road, an elevated highway can cost 20 million US dollars per kilometer. Is it 20? Just a moment, 20 into 20 million into 360. And yes, it's about 7.2 billion rupees. Yes, 7.2. Yes, this is a correct figure. The elevated highway can cost about 20 million rupees per kilometer. And then what you do is, if it is 3 kilometers of highway, you cannot actually charge for everything, because sometimes you are repeating, but if you have been different spans, different things, then you have to have different designs. So let's assume that The total length is total cost is 60 million US dollars. And you bring it down to about 25 million US dollars, 28 million US dollars. And then you are saving 22 million US dollars. 22 million US dollars, where 2.2 million US dollars will be yours. Because generally when you do value engineering, we cannot go up to about 30%, but in Sri Lanka, I mean, we have been doing a lot of work, and generally we have maintained something like 10% to make it very attractive for the engineers, because you will find that even this 2.2 million US dollars means 2.2 into 2.2 million into 360. That alone is 792 million. So you can see, by designing, by going for a value engineering solution, you can charge 792 million rupees. But whereas, had you gone for design, engineer will be paid 1% of it. That is 60 million, 1% means 0.6 million US dollars. So something that you can get only 0.6 million US dollars, because you have done a poor design. I come up and say, I can do a good design, and you as the original design engineer gets 0.6 million rupees, and I get 2.2 million US dollars, or I get 792 million rupees, whereas as the design engineer you will be paid only 200 million. About 200 million you will be paid, because this will involve your technical input, structural input, or the drawings, and then the drainage aspect. So every aspect, lighting, drainage, everything will be in that 216 million. Whereas I keep everything intact, but I change only the structure, and I earn 2.2 million US dollars. Whereas as the design engineer, you are paid only 0.6 million US dollars to undertake everything, including the site investigation. So you can see, suddenly, you are not doing damn well, and because your design is poor, has room for improvement, I step in and I earn a lot of money. So what I have shown you is how to do that, and I like you doing that, because I like you to do good value engineers for the world. Forget about Sri Lanka, because Sri Lanka is not very important market for you, and you can go for the real market, and that is the international market. And to go for international market, the important thing is, first important thing, getting up at 4 p.m., 4 a.m., and to sleep 9 a.m., 9 p.m., or 10 p.m. Because as you are getting mature, you can actually sleep less, especially when you are doing good exercises, and 4-kilometer walk, and cycling 30 minutes, or yoga. And if you are interested in yoga, you can actually try and learn it properly. And it's very important that you learn it properly, because if you don't learn it properly, you can make very big mistakes, and those mistakes can cause various injuries. So if you are doing it, do it properly. Otherwise, don't do it at all. So one of the good teachers is Mrs. Mala Veragoda, and her number is 722733138. She's very good in teaching. Then number 3, food intake, 2000 calories per day. Why? Then your brain is super. Not only in the morning, but even during the daytime it works well. And number 4, look for new technology, and that is Eurocodes. So you must learn Eurocodes and create your own methods to recall what is said in the Eurocode. So you must learn EC6, that is ET7, that is earthquake code, EC6, that is the foundation code, yes. EC5 is masonry code, masonry. EC7, yes. And we have again EC2, 2.1 and 2.2, both. All these codes must be pretty familiar with you. So the only way you can do that is get up at 4 o'clock and start working, because when the theory is anything that you do when your stomach is empty can be recalled easily. Anything that you do when your stomach is full, you cannot recall it. And one of the key things is reduce sugar intake, because sugar intake can affect you in various ways. So we have to reduce the sugar intake. So the idea is learn to drink plain cold tea. Plain tea but cold. That means not warm. Just lukewarm or no temperature at all. Learn to drink, and this is what Chinese do. It will do two things. One is no milk, no any kind of milk. And if you want to drink milk, have a yogurt or cheese or butter, but don't have margarine, because that is poison. So basically, again, don't have butter that is made out of palm oil. Go for real butter, the local butter. So Chinese, they drink a lot of tea, plain tea or green tea, but they smoke, but no cancer. Why? Because all these cancer cells will be destroyed in their body by this tea, and tea has little bit of kick, so your brain will work well, because it has little kind of small kick is there, so your brain will be very functional. Then you can do value engineering design, because you can see value engineering design is a very simple thing where we look at minimizing the amount of material by going for cellular rafts instead of pile foundations. But if the soil is very weak, over 20 meters, then we'll go for pile foundation. But if they have laterite soil about 3-4 meters below, then you will go for cellular raft foundation. And then we can think about PT, and then PT here, and then if you can manage the whole bridge with two box girders is even better. But when the bridges are very wide, then you might have to go for cellular box girders. So cellular box girder is it's not a good concept, because very difficult to construct it. So if you are going for box girders, then it's better to go for 3 box girders than 2 box girders as being cellular. For that, you must read books, and you must read the book by Hamley. Professor Hamley has written a very nice book, and you must read the book by Professor Hamley. And he died in 1995. He came to our university in 1994 and Perak the year November 1994. But unfortunately, he's a super engineer. But he died very young, something like 60, 62, I think maybe. He's not that old. He died in 1994, but he's a super engineer. He has a book called Bridge Deck Analysis. Bridge Deck Analysis. You might not understand most of the mathematics he's trying to tell you, because he's a mathematics guy who developed theoretical solutions for many things today we can do with finite element. modeling. So it's very important. If you want to be a good value engineer, you must become a master of MIDA Civil. MIDA Civil, because all your analysis will be based on MIDA Civil. Because in a highway, we get lorries crossing the bridge. So we need a bending moment envelope to do the distance. And one way or the other, you have to generate a bending moment envelope and a shear force envelope. That develop these two. The moment you do these two, and also torsional moments, if applicable. Torsional moments if applicable. So with all this, you can start. Then you will go for a grillage analysis. And once you model it as a grillage, you can easily get these diagrams and the torsional moment diagrams all can be obtained. And once you get the moments, bending moments, shear forces, and you know PT designs, how to do a PT design, is simply supported or continuous. There are different theories and different set of equations, and basically even simply supported one, you can use the same equation, but people sometimes use different equations. And all that part shall be done. Then basically you can come up with a good solution where you go for the high strength concrete. And then you'll ask, you did not explain us how to get the high strength concrete. In concrete, we have cement, and we can have fly ash, which I prefer going up to about 15%, fly ash to be around 15%. Then you have sand, aggregate, and water. And when you have no admixture, it can be 200 kilograms with reasonably good water reducing admixture, 180. When you go for a super plus size, it can go up to about 150, and it can be about 150, and it can even go down to about 100. So based on this, you can decide how much cement you need, right? So basically, start with. So I told the rule generally, if you want 30 megapascal concrete, and you are not going to do anything to 30 multiplied by 10 plus 50 kilograms of cement, and out of that 350, you can say, I'm going to use 300 kilograms of cement and 50 kilograms of fly ash. That is very much. Now you find you are going to use some of these admixtures, and you are going to use, instead of, if you use 200 kilograms of water, 200 divided by 350, the answer is 200 divided by 350, the answer is 0.57 water cement is. And now you decide to use 150 kilograms of water. Then 150 divided by 350, you will find now the water cement ratio has come down to 0.42 or 3. Then you might find, okay, why do we need 350? Well, can't we go for 330? So you try a mix with 330. Why? So when you go 330, then the water cement ratio is 0.45. Now you can see who is the killer? This is the killer, water. So if you want to get high strength concrete, use less water. But there's a problem, because we made concrete at the vacuum plant at Caledonia. We want to use it in Slave Island, and we need 2 hours of traveling because there can be traffic. So what will happen? We have to add a lot of admixture. We have to maintain a sump of 200 millimeters initially. to get the size specified sum of 220 millimeters that you need for concrete. Whereas my theory is don't do that. You go for site mix. Mix concrete at site with where you can mix 1 meter cube of concrete using a pan mixer. And you will ask why I advocate it. That's how we actually constructed bridges in the about 30, 40 to 50 years ago. We did the bridges without ready-mix concrete. And we use pan mixers at the site. We use admixtures. We reduce the cement content to such an extent, water content to such an extent that we could reduce the cement content as well. And then what we did was we maintained very low water cement ratios like 0.4 water cement ratio, even less. The moment you reduce the water, one way or the other vibrate the concrete, then you get super high strength concrete that gains the strength very fast. So what you do is, the trick is use admixture, reduce the water content, and the strength does not depend on sand and aggregate. It depends on cement, it depends on water. Cement can be high if you want high strength. Water has to be as low as possible if you want high strength. These two can be anything that you, but make sure use for aggregates. Sand, you use quarry dust, manufactured sand, then 6 millimeter chips, then 10 millimeter aggregates, 20 millimeter aggregates. So what do you get? You get a mix that can be compacted very well. And because the mix can be compacted very well, what can you say about the strength? Strength will be super strength. So you might get 55 megapascal in 28 days when you do this with minimum water, when you use 350 kilograms per meter cube. Have you ever heard 55 megapascal concrete obtained by using 350 kilograms of per meter cube of cement and a water content of 138, somewhere like that. And you'd ask, how did you hit 138? Because I mix the concrete at site. I don't need huge margins on slump. So I know what it is. Just by looking at the concrete, I can say whether I can compact it or not. So I don't need batching plants. I will do the manufacturing because these days labor is cheap. Labor rate is about 4,000 rupees per day. It's still cheaper to do it manually than using vehicles, because the diesel cost is 500 rupees per liter. It's about 500 rupees per liter, so there's no point in doing anything using machinery. Always use labor and go for optimization. Then you can actually get many things right. So that is the trick of value engineering. So value engineering means high strength concrete with very low water content and reasonable cement, because cement is very expensive. So don't overuse cement, use the minimum cement to get the correct strength, but look at the durability aspects, because when the cement content is very low, what are the chances of DEF? No problem with DEF, because DEF can occur only when the cement content, not the cementitious content. When the cement content is 275, very little DEF. When the cement content of 300 also, very low chance of getting. So the moment you know these data and all these data, how do you find it? And you can type MTR classing DEF, and you can download the research paper that we have published in IESL. We could have published that paper internationally, but we published it locally because we want to help you. So basically, the concept is go for high strength, go for pre-stress, try and avoid unnecessary foundations, work with a geotechnical engineer, because they are very, if you get hold of a super geotechnical engineer like Dr. Nayandi Sebla, you can do wonders because he understands. He can answer every geotechnical question that comes to your mind. So you go with the top people, because value engineering cannot be done by an average engineer. Value engineering can be done only by a top engineer who has vast knowledge. So that's why I spend some time, explaining things that may not look like relevant to this lecture. But why I explain Southern Highways, it's very important for you to understand. If you are a value engineer, don't do drastic changes, change gradually, so that you change gradually, and during that time you don't worry about the fee, but you worry about your experience. And the moment you gain more and more experience, you will go for super things that are very different, that are based on completely out of box. So that's the way the future. And make sure whether you are successful in Aragalaya or not, on 9th, one thing is the future will be very bright. Will be very bright, provided that we have honest leaders. And that is the requirement. So the moment you get it sorted out, we don't have to worry about this country, because we are not going to solve this country's problems. Once you master all these things, you can go for, you can link up with these Chinese companies, because they are very fond of our engineers. So link up with these Chinese companies doing a lot of work in Africa, and you can do a lot of these kind of design contracts, because your knowledge is super, and you can even become project managers in Africa for Chinese projects, because the Chinese don't know this kind of art of doing things. They are just doing in the traditional way. So the moment you go for this, there's a gold mine waiting for you. And what I tell all my students is, tap this gold mine by, they do BSc, then they do MSc, and then they go for PhD. And our target is, in 20 years, you are the CEO of a big company in US. That's our target. So we work with the vision, and to work with the vision, the most important thing is, don't jump into the first jump because somebody has said something. Always analyze the problem, identify the problem, and once you analyze, then you identify, then have some rational thinking and out of box thinking, and plan the solution very well. Once you do all these things, then you can come up with better solutions and innovative solutions. And always look out for things that you can see on the internet of very special solutions people have done, and try to appreciate, try to understand why they have done it that way. And the moment you start doing those things, you can get rid of the rust in your brain, because most of you have not used the brains properly since you passed out. Because most of the time you try to take the easy way out, and the easy way out means a difficult stage. And with that, I'll end the lecture. Engineer Kamala?
Yeah, thank you. Yeah, thank you very much, Professor. It's, I think, almost two and a half. Yeah, more than 2 hours.
Yeah, but you should know.
Thank you so much for this
information. It's all, I had everything stored in my brain.
It's a great that this eye-opening steps taken to do this lecture as value engineering for highway structures. Actually, this has to be applicable for, I think, almost all the engineering aspects. As engineers and decision makers, I think we have to give the attention for this. So thank you so much for this.
Okay, thank you very much.
Yeah, also I thank IESL Secretariat and IT team and this publicity department taking the steps to publicize the event and for hosting arrangements. Last, but actually not least, I thank you all for your active participation and have a wonderful evening to all of you. A very good night. Good night, Professor and everybody.